In this lesson, we are going to introduce the idea of a polar coordinate system. So rather than an xy, your point consists of an r and a theta. So a radius, a distance out from the origin, and some sort of an angle measurement. So here's the biggest difference going on. So it's the kind of grid that you have. So this is your normal x and y, just your normal rectangular coordinates. So you have x-axis and a y-axis. However, if you turn it into a polar, it is now a bunch of circles. So you have a radius, which are all these different circles. So like that one is a radius of 1, 2, 3, 4, 5. So just the bigger the radius, the further out you're going to be from the origin. And then here are your degree measurements. So pi over 6, 30 degrees, 60 degrees, 90 degrees, and then so on and so on and so on. And then you have 45s and different angles in there. But basically, you're talking about circles and where you're at on the circle. But it's not going to be on the unit circle necessarily. It's going to be the circles of varying radii. So if you are trying to connect the two and make some sense out of it. There is definitely a combination between the two. So first off, just a real quick, if you're going to plot a point, r, theta, you may be out a certain distance and up a certain value, right? So this is r. So let me come back to that in a second. But this point is r theta. And then if you happen to have a negative r theta, you're going to be the exact same, kind of just the exact opposite direction. So graphing a negative radius is like graphing the positive radius, but just now wherever you were, you're going to reflect it over to the other side. That's all the negative does, is it just reflects whatever your basic point would have been. So there's definitely a connection between polar and rectangular, and it goes with this idea that when you are at this point, r theta, that r refers to the radius, and your theta is a distance out. So what I like to think of this is, I drop this down, and all of a sudden x and y start to become the horizontal vertical pieces of my graph. So I can take this and go back and do stuff that I've done earlier in the semester of, if I know my angle and I know my radius, I can use SOHCAHTOA types of stuff to figure out what my x and my y are. Or there's a good chance that maybe it involves a special right triangle, so it's pieces of a 30, 60, 90 or something to that effect. But there is definitely a relationship going on, and you still have these relationships of sine of theta is going to be y over r. Cosine of theta is going to be x over r, adjacent over hypotenuse. And then there is still actually an equation of a circle. That. So there's definitely some relationships going on. And so here are some kind of connections between the two. That you have rectangular and polar. So it's that x equals r cosine of theta. So if you have r and theta and you want to figure out what the x value is, it's going to be r times cosine of theta, which is not a surprise, because if you would have set this up and you knew this value and this value, you would have multiplied the r over to isolate the x, which then the y value is r sine theta, just comes from solving for y on this one. And then you have that r is equal to the square root of x squared plus y squared. And all that is taking this equation of a circle that we would have had with this and isolating the r, so we square root both sides. So you can keep this in the back of your mind that if you have an r squared, you can replace it with an x squared plus y squared, and an x squared plus y squared gets replaced with an r squared. Or you can isolate the r altogether. And then there is one other combination that if you have tangent of theta is going to be the y value divided by the x value, which again just comes right from your picture. So these are some relationships that if you're going to go from this one to this one or this one to this one, you can have an x value and sub it out with an r cosine theta, or if you have an r cosine theta, you can sub it out with a rectangular. But there is going to be this going back and forth between the two. And so that's something to know, which really just all builds from something you're already familiar with. It's just taking some stuff and manipulating it just a little bit to get these a little bit more straightforward relationships going on. And so then we'll be plotting some points and converting some equations and doing some other things here in the next couple of videos.